In this video, we'll take a look at ColdWork as well as hardness. And so I want to highlight that in the text, they clearly walk through the ColdWork factor. And this can be applied to a number of different materials. You can look at the strain that results from ColdWork. You can see how the strength can be found based on the new reduced cross-sectional area, and how that's related. So the ultimate strength here is a function of the ColdWork factor and the original ultimate strength of the property. And so as you look at example 2.3, this is one, and it references a table. And so what I want to be sure is clear is that a lot of the data that you need can be found in a table. Let's see if I can make this any bigger. Very small. Okay, so for example, if I was looking at ASTM hot rolled or cold drawn steels, I could find that in table A20, A21. I think the text talked about table A22. So this was tensile tests of some materials, and so you can see here annealed 1018. You have hot rolled 1020. So you have a number of different types of materials and how they were conditioned, and then the yield and ultimate strength as you go across. And so for some of these problems, you're going to need to know what the original properties were. So for example, if you can see here, right, I have a problem in the textbook that uses annealed AISI 1018, and then I have repeat that problem for hot rolled 1212. I have repeat it for 2024 aluminum, T4 aluminum. And so the different materials, the big thing that changes, it's still 20% ColdWork operation. What changes is the properties of the starting material. And so as we're looking at ColdWork, that's what we're looking at. And so hardness testing is part of characterizing materials, and the Brinell hardness in particular is a roughly linear relationship between, for the ultimate strength. And so for steels, in the kilopounds per square inch, KSI, or in the megapascals here. So you have your ultimate strength as a function of your Brinell hardness number, and the same thing here for cast iron. So if I know my ultimate strength, I can determine my Brinell hardness number, and vice versa. If I know my Brinell hardness number, I can determine what the ultimate strength is for steel or for cast iron. And then example 2.4 talks about how if I have some of the information, for example, I have the ultimate strength and I know my Brinell hardness factor as a function of that. We go back one slide and we see, right, the ultimate strength is 0.23 HB minus 12.5 KSI. And then we can rearrange this. Let's see, I was doing cast iron. Yep, that's right. So we can rearrange this to find the Brinell number for that material. And so this is just a cursory glance at these properties here.